All right, we are ready to start our next topic. We are getting very close to the end of this topic, so we only have about 2 more days before we take our test. Today what we're going to do is discuss the properties of operations. So I want you to go ahead and set up your journal, 2 fresh new pages, and on the left-hand side I want you to title it Properties of Operations. And the objective today is to understand how to divide integers and identify the properties of operations. So go ahead and set up your journal, and then we are ready to get started. So this should be going on the left-hand side of your journal, but I want us to do a really quick recap on multiplying integers. So when we have 2 positive numbers that are being multiplied, for example, 4 times 3, we know 4 times 3 is 12, and 2 positive numbers together are also going to give us a positive number. So 2 positives gives us a positive. The same thing is the case with 2 negatives. So negative 4 times negative 3, right? We know 2 wrongs make a right. So together those 2 negative signs are going to give us a positive 12 as well. The only situation where you would have a negative response is if you have 1 positive number and 1 negative. So in this case, we have negative 4 and then a positive 3. So in this case, the 2 different signs is going to make our answer negative. All right, so let's go ahead and try these. So it says negative 2 and negative 7. So I'm going to go back to my 2 negative rules. Then that means my answer is going to be positive. And I know that 7 times 2 is 14. So my answer is going to be positive 14. Next one, I have a negative 10 and a positive 5. That is going to follow this particular rule of a positive and negative. So my answer is going to stay negative, and I'm going to multiply them out, and I'm going to get 50. Last but not least, I have a positive 3 and a negative 8. It's going to be the same rule as before, a positive and negative. My answer is going to stay negative, and 8 times 3 will give me 24. So just remember that when there's 2 different signs, my answer is going to stay negative. Now, one really important thing to note is that these rules are the same for division as well. So these rules are the same for division. So let's take a look at, let's use this example, 14 divided by negative 2. Well, here we have a positive number and a negative number, so it follows this particular rule. So my answer is going to be negative 7 as well. And if we were to rewrite this as a multiplication sentence, this is exactly what we got here, and it confirms our answer, right? We got positive 14, and our beginning statement here is also positive 14. So the division rules are the same thing as the multiplication rules. So if you feel comfortable with the multiplication, then you are going to feel just as comfortable with the division. Let's go ahead and try this problem on the right-hand side. It says right-hand side. So it says Channel 10 was tracking Hurricane Andrew in 1992. Hurricane Andrew was this huge hurricane that was back in the day. This was like back around the time that Miss Davis was born. And it pretty much destroyed Miami. It said if the hurricane changed the temperature in Miami by negative 13 degrees in 4 hours, how much did it change each hour? So you may not remember this, but this is actually a unit rate problem, right? If I were to represent this as degrees per hour, oops, I put digress. Degrees per hour, I would have 13 degrees on the top and 4 hours on the bottom. The question is, how do I get to 1 hour? Right? So whatever we do to the top, so to go from 1 to 4, I gotta divide by 4. So I gotta do the same thing to the top. I gotta do 13 divided by 4. Now, 13 does not go into 4 very nicely. So what we're gonna have to do is bring back our old knowledge of dividing decimals and try it out. So how many times does 4 go into 13? It goes into it 3 times. We get a 12. I'm left with a remainder of 1. Then I'm going to put a decimal point and bring down an invisible 0. How many times does 4 go into 10? It goes in 2 times. I'm left with 8. I subtract. I get a 2. And I bring back another invisible 0. How many times does 4 go into 20? 5 times. I get 20. And I'm left with a remainder of 0. So my answer in this case is going to be 325 degrees. Now, this was a negative 13. And what happens when we have a negative divided by a positive? Our answer also stays negative. So every hour, the degrees dropped 3.25. 3.25 degrees dropped every single hour. And after hour 4, that made it a total of 13. All right, go ahead and take a moment to copy down all of these properties on the left-hand side. There are a lot of them, and I want you to make sure you write them down. And once you're ready to continue on with the video, hit play, and I will explain each property. Make sure that you copy all of these down on the left-hand side of your journal, because these will be important notes. Okay, so there are 4 major properties that I want you to be familiar with. There is a 5th one that's pretty easy, and I didn't include it in the chart. But the first property is called the commutative property. And when you think about your commute to school, you start at your house, and then you go to school, right? On the way back, you go from school, and you end up at your house. So your commute is kind of like the way that you take to get home and to get to school. Now, no matter when you take your commute, whether it's in the morning or after school, at the end of the day, you're still hitting the same 2 spots, right? So the commutative property pretty much says that no matter what way I arrange my numbers in terms of addition and multiplication, I'm still going to get the same answer. 5 plus 3 is going to give me 8, and 3 plus 5 is also going to give me 8. It's still going to get me the same answer no matter how I arrange the numbers. The same thing with multiplication. 7 times 3 is 21, and 3 times 7 is also 21. So what you notice here is the numbers have flipped, but the answer is still the same. Now, this only works with addition and multiplication, because think about 5 minus 3 and then 3 minus 5. They don't equal each other, okay? This one's going to equal 2, and this one's going to equal negative 2, right? So with subtraction, it gets a little bit more complicated. So these properties are for addition and multiplication. No matter how you arrange the numbers, whether they're going one way or going the other way, they're still going to get the same answer. Now, the associative property, the second one right here, it talks about again, addition and multiplication. No matter who the numbers associate with, right, they're still going to also equal the same answer. So if you look at this particular case, 9 plus 1 are the numbers inside of the parentheses, and the 4 is the one hanging out by itself. But it would also give you the same answer if I had the 4 and the 9 inside the parentheses and the 1 hanging out by itself. Let's figure it out. 9 plus 1 is 10. And then plus the 4 on the outside, that's going to give us 14. Let's try the one down here. 4 plus 9, which is inside the parentheses, is 13. Plus 1 will give us 14. So these, in this particular case, no matter who's inside the parentheses, we're still going to get the same answer if it's all addition, okay? All of them are addition. The same thing with multiplication over here. They're all being multiplied, but the numbers that are hanging out inside of these parentheses are different. Okay, so at the end of the day, when you solve it, you're still going to get the same answer. So that is the demonstration of the associative property. When you think of associate, it means who you want to hang out with, who you like to associate yourself with, who you like to say, oh, I hang out with this person, I'm cool with them. So think of it in terms of that way, like who is being associated with each other in the parentheses might change. But at the end of the day, you're still going to get the same answer, okay? The third property is the identity property. And the identity property means that at the end of the day, I want the answer to look the same as one of the numbers inside of the expression. Now, that sounds really confusing, but think of it in terms of addition, right? My first number in this case is 9, right? And I want my answer to also be 9. right? So what do I have to add to 9 to get the same number? 0, right? I can't add anything to 9 to get the same answer. So identity means who you are, who you represent. So in this particular case, 9 wants its identity to be equal. It wants, after the equal sign, there also be a 9. So in terms of addition, that means we have to add 0. In terms of multiplication, I have 6, and I want my identity or my answer to also be 6. That means that I have to multiply it by 1. What happens if I multiply it by 0? Do I get 6? No. If I do 6 times 0, I'm going to get 0. So that's why with multiplication, the identity property talks about 1, because any number times 1 will give you itself, will get you the identical number. Last but not least, and you learned this last year, and this is a very, very important property because it never goes away, is the distributive property. The distributive property has 2 operations. So there's addition in the middle, and then there's a number on the outside, and what that means is multiplication. I want to take this number and I want to multiply it to everything on the inside. So let's think of this example. I have a class of 3 students and another class of 4 students, and I want to distribute two bags of candy to each class. So the question is, how do I figure out what this is going to equal? There's 2 ways to do it. What you could do is you could add 3 plus 4, right, and you get 7, and then multiply it by 2. Or you could use the distributive property, where you multiply 2 times 3, and then you add it, because that's the symbol in between, you add it to 2 times 4. Okay, so 2 times 3 is 6. 2 times 4 is 8. 6 plus 4, or 6 plus 8 gives you 14. So that confirms the same answer that I got before by adding these 2. But you can also apply the distributive property where you're distributing, you're passing out the 2 to everything on the inside. Okay, so this lesson was pretty much definitions and understanding identities. What I want you to do now is I have 2 links here, and I've also posted them on the Edmodo group. One of them is a game on the properties of multiplication and addition, and the other one is on multiplication and division of integers. I want you to take some time for the rest of the period to play those games and practice your fluency, meaning getting better at answering these questions faster as opposed to having to sit there every time and read rules. So go ahead, log into Edmodo, access these games and play them using your notes and just using your own understanding of these rules so that you can move through these problems quicker. You will have a quiz at the end of the class today.